All right, so today our topic is going to be on the operations with functions. So operations are simply just adding, subtracting, multiplying, dividing fractions, or operations are adding, subtracting, multiplying, dividing anything. And what we're going to be adding, subtracting, multiplying, dividing are just functions. And so let's first take a look and see when we might use something like this. So let's just write a function, first of all, that represents the distance a plane is from an airport when traveling 325 miles per hour. And we could describe this function as f of x equals 325x, simply because in 1 hour, the plane is going to be 325 miles away. And in 2 hours, it'd be 325 times 2, or 650 miles away. And we can just multiply 325 times the number of hours and get the distance the plane is from the airport. At the same time, we want to be able to write a function that represents the distance of anything that is caught in a 30 mile per hour tailwind. So it's something that's being pushed by a 30 mile per hour wind after x hours. And we can describe this with we're going to call it g of x, and that's simply 30 times x, which means every hour it travels 30 miles. So in 1 hour it'd be 30 miles away, in 2 hours it'd be 60 miles away, and so on. So what we're going to work on today is something that happens with both of them are occurring at the same time. So we're going to write an equation that represents both forces on an airplane happening at the same time. In other words, it's flying 325 miles per hour on its own, but it's also being pushed by a 30 mile per hour tailwind. And so what we're essentially asking you to do on a problem like this is to add those two functions together. So we can either write this as f of x plus g of x, or we can write it as f plus g of x. But really what we're doing is we're taking the f of x function and we're adding it with the g of x function. So if we do that, the f of x function is 325x, so we have 325x, and we're adding to that the 30x. And so if we put those together, that's really sloppy, but if we put those together, both of them are going to end up being 355x. It just means the same thing, just different ways of adding, or just ways of denoting that we're adding those two functions together. So 325x plus 30x is 355x. So what that means is that every hour the plane is going to be traveling 355 miles. And so after 2 hours, it'd be 355 times 2, or 710 miles away, and so on. So let's write a different function that represents the same airplane, but this time instead of traveling against the 30 mile, or with the 30 mile per hour wind, it's traveling against the 30 mile per hour wind. And so we want to take the f of x function, except this time we're going to subtract the headwind. We're going to subtract the g of x function. And so it's going to look like this, where we have f of x minus g of x, or we could simply write it as f minus g of x. And if we subtract 325x minus 30x, we're going to get 295x. So there's two situations where we would really want to add functions together. Let's just take a look at some more of these situations. Let's say we have two functions, f of x and g of x. And what I would want you to do is, if you're watching this video, pause the video and see if you can perform these three operations on your own, and then we will continue the video after you have attempted it on your own. So I'm going to suppose that you guys have done that, and what we're going to do now is we're going to add the f of x function plus the g of x function. And so the f of x is 3x minus 6. The g of x is x squared minus 2x. And when I add those two things together, I can add the like terms. And so I would say that f of x plus g of x is going to be, I have an x squared, but that's the only x squared term I have. I have a 3x and a negative 2x, which is, if I put them together and add like terms, 3x and a negative 2x is just x minus 6. And so when I add these two things together, what I get is x squared plus x minus 6. Now let's subtract these two things. This one might require a little bit more work. We're going to take the 3, actually we're going to start with the g of x. So we're going to start with x squared minus 2x, and we're going to subtract this whole function, 3x minus 6. And so when I do this, the x squared minus the 2x won't change. But then I'm going to subtract this whole thing, which means I'm going to distribute this -1. So it's going to be minus 3x and then plus 6. So when I combine my like terms, I'll have x squared, and then -2x and -3x is -5x, and then plus 6. And that's what g minus f of x would be equal to. All right, so let's take a look at number 3. Number 3, I'm going to set up the equation as 3 times the f of x function, which is 3x minus 6. And then it's going to be minus 2 times the g of x function, which is x squared minus 2x. And so I'm going to start by getting rid of these parentheses using the distributive property. 3 times 3x is 9x. 3 times -6 is -18. And then I'm going to take -2 and distribute that. -2 times x squared is -2x squared. And -2 times -2x is actually positive 4x. And then I can combine like terms. I have the -2x squared first. So there's my x squared terms. Then I have 9x plus 4x, which is 13x. And then minus 18. And so there you have 3 times f of x minus 2 times g of x. And so hopefully you had somewhere close to these 3 answers when you tried it yourself. But if not, hopefully you learned from that so that when it comes time for you to do it on your own, on your homework, you can do that. All of those dealt with adding and subtracting. What we want to do next is work on multiplying and dividing. So let's take a look at number 4 first. We're going to multiply these two things together. So I'm going to take the f of x function, which is 3x minus 6, and I want to multiply that times the g of x function, which is x squared minus 2x. Now, hopefully you remember a little bit from Algebra 1 that when we multiply two binomials, that's two terms in the first thing that we're multiplying and two terms in the second thing, we're going to have to FOIL. Or double distribute, however you want to think of it, but I'm going to take 3x times x squared. Well, that's 3x to the third. And then I'm going to take 3x times -2x, and that's -6x squared. Then I'm going to multiply the -6 out. -6 times x squared is -6x squared. And -6 times -2x, well, that's positive 12x. So when I combine all of my like terms, I'm going to have 3x to the third minus 6x and minus 6x is minus 12x squareds. And then I have plus 12x. So this is what I should get when I multiply those two equations together, or those two functions together. Now let's take a look and see what happens when we divide the two of them. I'm going to have f of x, which is 3x minus 6, over g of x, which is x squared minus 2x. And really what I want to do here is see if anything can be simplified. And so hopefully you remember a little bit about factoring. I can take the numerator and I can actually factor a 3 out. 3 times x minus 2 gives me 3x minus 6. So I'm just factoring a 3 out of that expression. And then on the bottom in the denominator, I'm going to factor an x out. And so x times x gives me x squared, and x times negative 2 gives me negative 2x. And so now, because I factored those two out, these two factors can cancel each other out, and my final answer is going to be 3 over x. And so this is what I have as my final answer for f of x divided by g of x. Now, there is something that we want to watch out for, especially when we divide, and that is what the domain is. The domain is anything that we can plug in for x that actually gives us an answer. We really don't have to worry about it for number 1 or number 2 or even number 3, because in all three of those examples I can stick anything that I want in for x and it's going to give me an answer. I can stick in positive numbers, I can stick in negative numbers, I can even stick in 0, and I would always get an answer. Same thing with number 4. No matter what I stick in, I can always cube any number, I can square any number, and I can multiply any number times 12, and I can add them together. But I do have a problem with number 5, because not every number is going to work. There's actually 2 numbers in number 5 that's going to give me something that doesn't give me an answer back out. One of them is that x cannot be equal to 0, because x cannot equal 0. Because if x was equal 0, we're going to have 3 divided by 0, and that's just undefined. We just can't do that. And even though it's not in the final answer, there's another number that x cannot equal, and that is that x cannot equal 2. You can see right here that if x was 2, we would have a 0 in the denominator, and we don't want to have that, so it can't be 2 either. As a matter of fact, in this process right here, if x was either one of those, we'd have a 0 in the denominator. So when we ask what is the domain, we could write the domain like this. The domain is all the x values such that x does not equal 0 or 2. And this is how we would write that using set notation. That's an or right there. So x does not equal 0 or 2. So hopefully that makes sense to you. So this is what we're going to be doing on our homework assignment, and we will come back tomorrow and go over questions that you have.